Okay, so we have a certain spring that obeys Hooke's law. So Hooke's law is F equals minus K delta X. The work done in stretching the spring by 10 centimeters is 4 joules. So now we're talking about energy. So our energy our energy is then, or potential energy, I should say, our potential energy is 1/2 kx squared. And this comes from the fact that our potential energy is minus integral of force dx, where in this case we would use x in here, not delta x, but it's just assumed known that this is our delta x. Okay, and so if we integrate this expression, we will get 1/2 kx squared. Okay, so if we want to increase our energy if we increase our x by 10 centimeters, then we're increasing our energy by 4 joules. Or another way of saying this is that 4 joules is 1/2 k times 10 centimeters squared. Now, I guess this assumes that we're starting from x naught, but we don't need to, because in essence what this expression is telling us is that for every x we move, we increase our energy by a squared amount. But in any case, we can leave this like this. And so how much additional work is required to stretch the spring an additional 10 centimeters? So if we want to know now our energy for this, given this, well, we can solve for our k by saying that it's 8 joules over 10 centimeters squared, or plugging this in, we would have 4 joules over 10 centimeters squared. I shouldn't have taken those out. So this is doing it quite simply without running anything through a calculator yet. And so then this is 4 joules times 20 over 10 squared, which is 4 joules times 2 squared. Right, because 20 over 10 is just 2. And so if we double our distance, then we multiply the energy by 4. And so that's kind of that's really the takeaway here. Or we square whatever the factor is that we're adding. And so it would be 16 joules. But the question asks how much additional work. Right, so in stretching it to 10 centimeters, we did 4 joules. In stretching it to 20 centimeters, which, sure, that's double, let's go with that, is 16 joules. So the additional work is just in here. So that would just be 16 joules minus 4 joules, which is then 12 joules. So there's 12 joules of additional work. Okay. So yeah, so we could calculate the K and get an actual value, which is done in the solution here. And then we could just plug it in to get our total work to get to 20 centimeters, but then the additional work is then just 12 minus or 16 minus the 4, sorry, which gives us our 12 joules. So that looks good.